All right, today we're going to be going over the distance formula. Now, the distance formula is just a formula used to find how far two locations are from each other. So the distance formula is given to you at the top of the screen here. It's d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, x2 and x1 are just locations on the graph or locations on a map. And you're finding the distance between those two. So what we're going to do is we're going to go over a couple examples, starting with this first one. Example 1 gives us two locations, an x and a y, and then a second x and a y value. I'm going to go ahead and label the first x and y value x1 and y1. And then the second x and y value I'm going to call x2 and y2. All right, so those are our numbers that we're going to place into the distance formula. All right, so I'm going to rewrite the formula here. I'm going to write d equals, I'm going to write the square root. But instead of writing my x2 and x1 in my first parenthesis, I'm going to write the numbers that represent those. So 4 is my x2 minus 1, which is my x1, squared. So it's always to the second power. All right, plus my y2, which is 1, minus my y1, which is 5. Again, to the second power. Now, if you're really good at using the calculator, you can plug this in, but you got to be very careful with the parentheses. However, we can break it down here, so we can do our math and figure out what 4 minus 1 is. That would just be 3. And then remember it's squared. And then 1 minus 5 would be negative 4. And that's also squared. And remember, all this is still got the square root over it. Our next step here would be to actually square the 3. So 3 squared is 3 times 3, which is just 9. We're going to add that to negative 4 squared, which is negative 4 times negative 4. That would be positive 16. Remember, this is all still square rooted. And then our last part in solving this would be to add 9 and 16 to get 25. And again, it's still square rooted. But we should know that the square root of 25, and if you don't, you can put this in your calculator, but the square root of 25 is just 5. So our answer in the end is going to be 5. So that means that these two locations are 5 units apart. Sometimes our units can be in feet, miles, centimeters, inches. In this case, they don't give you a unit of measurement, so we just call them units. So 5 units apart. That's the distance between those two. All right, we're going to take a look at example 2 here. All right, example 2 gives us a brief little story problem. It asks us on a map if Mott is located at negative 1, comma 5, and Kettering is located at 12, comma negative 3. Find the distance between the two schools. All right, so we're going to do the same thing we did in the last problem. We're going to go ahead and label our first point x1 and y1. So that's where Mott's located. We're going to label our second point x2 and y2. And that's where Kettering is located. And now we're going to use our distance formula to find the distance between these two schools. So I'm going to write d for distance. I'm going to put a big square root, a big radical. And I'm going to subtract my x2, which is 12, and my x1, which is negative 1. squared. I'm going to add and then subtract my y2, which is negative 3, and my y1, which is 5, squared. Okay, so this time I have my equation. I'm going to go ahead and start doing the math inside of it. So 12 minus a negative would be like adding, so that's going to be 13 squared. Negative 3 and negative 5 becomes a bigger negative. That's going to be negative 8 squared. All right, now I'm going to take my calculator. I'm going to do 13 squared, which is 169. I'm going to do the same thing for negative 8 squared. It's 64. If you're getting negative 64 for that one, then you need to make sure you include your parentheses around the negative 8. I'm going to add these two together. So 169 and 64. I end up with 233. And then I have to square root 233 to get my final answer. I end up with about 15.26. All right, so that is our distance between those two schools. All right, moving on to example 3. We're going to be doing the same thing that we did in the previous two problems, only now we're going to be given a graph to look at. So we're going to be given two locations on a graph on a coordinate plane. And our first step is to first label what those 2 points are that we're trying to find the distance of. So we're going to look at n. N would be 1 unit to the left. So that would be negative 1 for my x value. And then 1, 2, 3, 4 units up for my y value. So n is at negative 1, comma 4. All right. M is at 1, 2, 3, 4, negative 4 for the x value, and negative 1, because it's 1 down, for the y value. So that's negative 4, negative 1 for the location of M. All right, now I'm going to take these numbers and I'm going to put them into our distance formula. So I'm going to take the two x values and I'm going to subtract them. I'm going to start with the M, negative 4, minus our first x value for n, which would be negative 1, and I'm going to square it. And I'm going to add that to the difference between the y values. So my first y value and my second y value are going to be subtracted from each other. I'm going to do negative 1 minus positive 4. Again, that's squared. All right, so there's a lot of negatives in this one, so you have to be very careful. If you're putting in your calculator, put it in exactly like it looks. The first parenthesis will end up being negative 4 minus a negative would be like adding 1 to negative 4, so that would be negative 3 squared plus negative 4 and negative 5 would, or negative 1 and negative 4 would be negative 5 squared. And all this is still square rooted. Negative 3 squared is just 9. Negative 5 squared is 25. We're going to add those together and then square root it. So when we add them together, we end up with a square root of a 34. And it's not a perfect square, so we are going to have to use our calculator. You should get something like 5.8. And we're rounding there. It's slightly bigger than 5.8, but right around 5.8 for the distance between M and N. All right, in our last example, we're finding the distance between A and B. Now again, we're going to find the location of A and the location of B first. So A is located at 1, 2, 3, 4, negative 4 for the X, and 1, 2, 3, 4, positive 4 for the Y. And then B is located at 0 for the X, because we don't move left or right there, and then just 1 down. So 0, 1. So those are our values for A and B. Now I'm going to call A my X1 and Y1. I'm going to call B my X2 and Y2. It doesn't matter which one we call. The X2 or the X1 or Y2, they could be switched. But just so it helps me plug it in, I'm gonna go ahead and label those. And now it's just a matter of plugging it into the equation correctly. So X2 goes first, that's 0. Minus X1, it's negative 4 squared. Y2 is 1. Minus 4 squared. And now 0 minus a negative would be positive 4 squared. 1 minus 4 is negative 3 squared. All right, so 4 squared is 16. Negative 3 squared is positive 9. I'm going to add those two together to get the square root of 25. And then I end up with a distance of 5. All right, so there's two ways that we're going to be using these. You're going to be given 2 points, and you're going to have to find the distance between those 2 points. Or you're going to have to find the location of 2 points from a graph, and then you're going to have to find the distance between those two locations on a graph. All right, try these 2 practice problems on your own. If you need, you will need to pause the video. So go ahead and pause it now and try problems 1 and 2. The answers will follow.